Good day, learners! Welcome to General Mathematics Learn by Video series. This is brought to you by QuexBook Smart Mobile Learning and PerkDC Learn Hub. I am Engineer Rex Jason H. Agustin, ninth placer in the March 2015 Licensure Examination for Teachers, major in Mathematics, and board passer in the October 2009 Electronics Engineering Board Exam. We are now on our new topic under Basic Business Mathematics. In this video, we are going to discuss simple and general annuities. In our previous video, we just finished discussing simple and compound interest. So we can now finally put a check mark on the box of simple and compound interest. Now, we're going to focus on simple and general annuities. Please get your pen, paper, and calculator so we can get started. Our targeted most essential learning competency illustrates simple and general annuities. For the topic outline, we have definition of annuity, classification of annuity based on interest period and payment interval, classification of annuity based on payment schedule, classification of annuity based on duration, and simple annuity. In line with the MELC, our learning objectives are to define annuity, to know the different classifications of annuities, and to illustrate simple annuity. Are you ready? Let's get started. Annuity. Annuity A is a series of uniform payments made at equal intervals of time. We have here a cash flow diagram representing annuities where A represents the fixed amount of money made at regular intervals. This A can be 1,000 pesos, for example. So if A is 1,000, we have 1,000 pesos at the end of first year, another 1,000 pesos at the end of second year, another 1,000 pesos at the end of third year, until another 1,000 pesos at the end of nth year. Okay? The intervals does not necessarily have to be yearly. The intervals can be monthly or quarterly. Okay? Some of the real-life examples that we have for annuities are monthly salaries, where the worker receives a fixed amount of money every month, and apartment rentals, where the boarder pays a fixed amount of rent, okay, every month. Those are examples of annuities. Annuities can be classified in many ways. Based on interest periods and payment intervals, annuity can be classified into two: simple annuity and general annuity. This will be the focus of our discussion in this series: simple annuity and general annuity. Simple annuity is an annuity in which the number of compounding periods per year coincides with the number of annuity payments per year. Okay? For example, the payment is made yearly and the interest rate is also compounded yearly. Okay? That is an example of simple annuity. Another example is that payments are done quarterly and the interest rate being charged is also compounded quarterly. That is simple annuity. Next, general annuity. General annuity is an annuity in which the annuity payments and compounding periods do not coincide. For example, the payments are done yearly, but the interest rate is compounded semi-annually. That is general annuity. Or another example, if the payments are done quarterly, but the interest rate being charged is compounded monthly, That is general annuity. Okay? Annuity can also be classified based on payment schedule. Based on payment schedule, annuity can be ordinary annuity, annuity due, or deferred annuity. Ordinary annuity is an annuity that is paid or received at the end of the time period. Say for example, monthly salaries. Most of the working people receive their salaries at the end of the month, right? That is a fixed amount of money, which is the salary, is being received regularly, which is every month. Well, of course, that is considering that there will be no deductions for tardiness or absences, right? Next, annuity due. Annuity due is an annuity that is paid or received at the beginning of the time period. For example, the apartment rentals. The boarder has to pay the rent first before he can actually occupy the apartment, right? So payment is made at the beginning. That is annuity due. Okay? Next one, we have deferred annuity. It is an annuity in which the first payment is delayed or deferred for a period of time. Okay? For deferred annuity, several periods will pass by without annuity. But after a certain number of periods without annuity, we can see regular payments or deposits after that period. Okay? Say for example, for the whole first year, there are no deposits made in a bank account. And after 1 year, we will be able to see monthly deposits of 1,000 pesos for 3 years. That is an example of deferred annuity. Okay? Annuity can also be classified based on duration. And based on duration, annuity can be classified into two: annuity certain or contingent annuity. Annuity certain. It is an annuity where the payments are made for a fixed or deterministic period of time. Say for example, yearly payments for 10 years. That is annuity certain. Or another one, quarterly payments for 3 years. That is still annuity certain. Okay? If the length of time is deterministic and infinite, the annuity is called a perpetuity. Perpetuity is a special case of annuity certain which continues forever. N is equal to infinite. It is deterministic. It's just that we know that it lasts forever. That's perpetuity, a special case of annuity certain. Next, we have contingent annuity. Contingent annuity is an annuity in which the payments extend over an indefinite or indeterminate length of time. Okay? Indeterminate length of time. Say, for example, monthly pension for a person until he dies. Okay? We cannot determine when will a certain person will die, right? So that's indefinite length of time. That is an example of contingent annuity. Okay? Let us now focus on simple annuity. For grade 11 senior high school curriculum, the focus is only on simple annuities and general annuities. Okay? Let's have example number 1. Suppose Rafael Asher, a high school student, would like to save 5,000 pesos every year in a fund that gives 10% compounded annually. How much is the amount or future value of his savings after 4 years? This is an example of simple annuity because it is written here that Rafael Asher will save 5,000 pesos every year and the interest is compounded annually. Okay? That is an example of simple annuity. We are going to show two solutions for this example. And for solution number 1, we're going to draw a cash flow diagram, okay, to see what's happening with his savings. At the end of first year, Rafael Asher will deposit 5,000 pesos in his account. And at the end of second year, he will again deposit another 5,000. At the end of third year, he will deposit another 5,000. And on the fourth year, he will deposit another 5,000 pesos. Using the compounding interest formula, F is equal to P plus I raised to N, we are going to compute for the future value of each deposit. This 5,000 pesos on year 4 is just 5,000 pesos at the end of fourth year, right? This 5,000 pesos deposited at the end of third year will become 5,000 times quantity 1 plus 0.10 raised to 1. We apply this formula, okay? Interest rate per period is 10% or 0.10, okay? And from third year to fourth year, it is just one interest period. Okay, we have an interval of 1 from 3 to 4. Okay, this is equal to 5,500. This 5,000 pesos deposited on the second year will become 5,000 times 1 plus 0.10 raised to 2. We just use this formula again. Okay, from 2 to 4th year, or from second to fourth year, we have two intervals. That's why we use 2 for the exponent. Okay? 5,000 times 1 plus 0.10 raised to 2, that is equal to 6,050. And the 5,000 pesos made on the first year will be 5,000 times 1 plus 0.10 raised to 3, okay, which is equal to 6,655. For this, we have three intervals from first year to fourth year. Okay? We just use this formula F is equal to P times quantity 1 plus I raised to N. Now, let us just add all the values obtained from this one, from this step. 5,000 plus 5,500 plus 6,050 plus 6,655, that is equal to 23,205. Okay? Therefore, the amount of his savings after 4 years is 23,205. Okay? Now, let us show another solution for this problem. Solution number 2. We can actually solve this problem by using the derived formula for the future value of annuity. F is equal to A times quantity 1 plus I raised to N minus 1 over I. Okay, where A is the annuity or the amount of regular payments or deposits, I is the interest rate per period, and N is the number of payments or deposits. Let's show the cash flow diagram once again. We have 5,000 deposited on the first year, 5,000 deposited at the end of second year, 5,000 deposited at the end of third year, and another 5,000 deposited at the end of fourth year. Okay? Our given, we have A, that's 5,000 pesos. That is the amount for regular deposits. I is equal to 0.10 or 10%. That's 10% compounded annually. And N is equal to 4. Now, we're going to compute for the value of his savings after 4 years. Okay? We have here 5,000 pesos deposits. N is equal to 4. Okay? Just substitute the given to this formula. We will have 5,000 pesos times quantity 1 plus 0.10 raised to 4 minus 1 over 0.10. Using your calculators, okay, we should get the same answer, 23,205. Okay? The amount of his savings after 4 years is 23,205. Now, some of you might be asking, where did we get that formula that we use in example number 1? Here is the answer. Here is the derivation of that formula. Here is our cash flow diagram. We have payments made regularly, okay, fixed amount of payment A, done during the first, second, until the end period. We just need to get the future values of these payments or deposit and bring them on period N. This payment made at period N is just A. This payment made at period N minus 1 will be A times A plus I, right? Okay, between N minus 1 and N, we have only one interval. And so on until we consider this one. In the future, this will become A times 1 plus I raised to N minus 2. Okay? And if we consider this first payment or deposit, in the future, it will become A times 1 plus I raised to N minus 1. Okay? Computing for the total future value, we have F is equal to A, that's for this one, plus A times 1 plus I, that is for this one, until that A times 1 plus I raised to N minus 1, that is for this one. Okay? We will call that equation number 1. Multiply both sides by 1 plus I to get F times 1 plus I. So we multiply this by 1 plus I. Okay? And this now, A will become A times 1 plus I. This A times 1 plus I will now become A times 1 plus I squared until this A times 1 plus I raised to N minus 1 will become A times 1 plus I raised to N. Okay? We will call this equation number 2. Now, subtracting equation number 1 from equation number 2, we can cancel A times 1 plus I plus and so on until A times 1 plus I raised to N minus 1. And this one, A times 1 plus I plus and so on until A times 1 plus I raised to N minus 1. Okay? So we will have F times 1 plus I, that's this one, minus F, that's this one, is equal to A times 1 plus I raised to N, this one, minus A, this one. Okay? Next, we can factor out F. Okay? And we will have F times 1 plus I minus 1. And on the right side, we can also factor out A. And we can have A times quantity 1 plus I raised to N minus 1. On the left side, we can cancel 1 and minus 1. So on the left side, we will just have F times I. And on the right side, we still have A times quantity 1 plus I raised to N minus 1. Okay? F times I is equal to A times quantity 1 plus I raised to N minus 1. Then transpose I to the other side of the equation. We will get the future value of annuity is equal to A times quantity 1 plus I raised to N minus 1 over I. Okay? You can add this to your list of formulas for annuities. Let us have example number 2. How much money should you invest today in an account that earns 5% compounded annually in order to withdraw 10,000 pesos every year for 4 years. Again, this is an example of simple annuity. The withdrawals are made every year and the interest is compounded annually. Okay? This is simple annuity. For this example, we are going to show again two solutions. For solution number 1, we're going to show a cash flow diagram to clearly see what's happening with the money. Okay? A withdrawal of 10,000 pesos will be made after 1 year, another withdrawal of 10,000 pesos at the end of second year, another withdrawal of 10,000 pesos at the end of third year, and another withdrawal of 10,000 pesos at the end of fourth year. Okay? Using the compounding interest formula, P is equal to F over 1 plus I raised to N. Remember this one? This is our formula for compound interest computations, right? Compute for the present value of each withdrawal. Okay? Let's bring this 10,000 at the end of first year at time is equal to 0. Using this formula, we will have 10,000 over 1 plus 0.05. Our interest rate is 5% or 0.05. Okay? This is equal to 9,523.81. This 10,000 pesos at the end of second year, when brought at time is equal to 0, will have a value equal to 10,000 over 1 plus 0.05 squared. That is equal to 9,070.29. Okay? We're just using this formula. Next, this 10,000 withdrawal to be made at the end of third year has an equivalent present value equal to 10,000 over 1 plus 0.05 cube, which is equal to 8,638.38. And then this 10,000 withdrawal at the end of fourth year has a present value equal to 10,000 over 1 plus 0.05 raised to 4. And that is equal to 8,227.02. For our next step, we just add all the present values obtained in this step. That is 9,523.81 plus 9,070.29 plus 8,638.38 plus 8,227.02. And that is equal to 35,459.50. Therefore, the amount that you should invest today is 35,459.50 in order to have 10,000 pesos withdrawal every year for 4 years. Okay? Let us try solving example number 2 again, but this time with a different solution. Okay? Solution number 2. Let's just show this cash flow diagram again. This can serve as our guide in our solution. We can actually solve this problem by simply using the formula P is equal to A times quantity 1 minus 1 plus I raised to negative N over I. This is the derived formula for the present value of annuity, where A is equal to annuity or amount of regular payments or deposits, I is the interest rate per period, and N is the number of payments or deposits. In this case, we have withdrawals. Okay? A is equal to 10,000 pesos. This is the fixed amount of our yearly withdrawals. I is equal to 0.05 or 5%. We have here 5% compounded annually. Okay? And N is equal to 4. We're going to have 4 withdrawals. 1 every year. Okay? Substituting the given to this equation, we will have present value P is equal to 10,000 times quantity 1 minus 1 plus 0.05 raised to negative 4 divided by 0.05. Okay, just press this in your calculator and you should get the same answer, 35,459.5. Okay? Therefore, the amount that you should invest today is 35,459.50 in order to withdraw 10,000 pesos every year for 4 years. Alright. Now, some of you might be asking again, where did that formula came from? So let's show our derivation for the formula of present value of simple annuity. Let's make use of this cash flow diagram. In this cash flow diagram, we can see regular payments A made at equal intervals of time. Okay, we have payment or withdrawal A made at the end of first year, regular payment or withdrawal A made at the end of second year until period N. We just need to bring this at T is equal to 0. Okay? Regular payment A made at the end of first period has a present value equal to A over 1 plus I. This payment or withdrawal A made at the end of second period has a present value equal to A over 1 plus I squared. And so on until this payment or withdrawal made at period N-1, it has a present worth equal to A over 1 plus I raised to N-1. And lastly, this payment or withdrawal A made at period N has a present value equal to A over 1 plus I raised to N. Computing for the present value, we just need to add all of this and we will get present value P is equal to A over 1 plus I plus A over 1 plus I squared plus and so on until plus A over 1 plus I raised to N minus 1 plus A over 1 plus I raised to N. We will call this equation number 1. For our next step, we multiply both sides by 1 over 1 plus I to get P times 1 over 1 plus I. We just multiply this P with 1 over 1 plus I. Okay? That is equal to A over 1 plus I squared. That is from this one, A over 1 plus I multiplied by 1 over 1 plus I. Okay? That will become A over 1 plus I squared until this A over 1 plus I raised to N multiplied by 1 over 1 plus I becomes A over 1 plus I raised to N plus 1. Right? We can call this equation number 2. Next step, subtract equation 2 from equation 1. When we subtract these 2, we can cancel A over 1 plus I squared until A over 1 plus I raised to N. Okay, we also have it here. A over 1 plus I squared until A over 1 plus I raised to N. So subtracting the 2 will give us P, that is from equation 1, minus P times 1 over 1 plus I, that is from equation 2, is equal to A over 1 plus I, that is from equation 1, minus A over 1 plus I raised to N plus 1, that is from equation 2. Okay? Next, on the left side of the equation, we can factor out P and we can write it as P times quantity 1 minus 1 over 1 plus I. Okay? And on the right side of the equation, we can factor out a over 1 plus I. We can factor out a over 1 plus I. We can write it as a over 1 plus I times quantity 1 minus 1 over 1 plus I raised to n. Okay? Okay. Next, on the left side of the equation, this 1 minus 1 over 1 plus I can be written as 1 plus I minus 1 over 1 plus I. Okay? If we write it this way, we can now cancel 1 and minus 1. Okay? Okay. Next, if this is already cancelled out, we can now cancel 1 plus I on the left side of the equation and 1 plus I on the right side of the equation. Okay? So now, on the left side of the equation, we only have P times I. And that is equal to A times quantity 1 minus 1 over 1 plus I raised to n. Okay? That's P times I is equal to A times quantity 1 minus 1 over 1 plus I raised to n. Okay? Next, this 1 over 1 plus I raised to n can be written as 1 plus I raised to negative n. Okay? Remember the properties of exponent. Next step, we just need to transpose I to the other side of the equation, and we will get present value P is equal to A times quantity 1 minus 1 plus I raised to negative n over I. Okay? You can add this to your list of formulas for simple and general annuities. Alright? That's it for today. Now let's check what we have learned. We were able to define annuity. We were also able to know the different classification of annuities. And in this session, we were also able to illustrate simple annuity. Okay? In our next video, we are going to continue our discussion on simple and general annuities. We're going to have part 2. We're going to continue illustrating simple and general annuities. We still have to illustrate general annuities, right? For more related practice problems, you may use our QuexBook General Mathematics app available from Google Play Store and answer Chapter 4. I hope that you've learned something from this video. See you next time. God bless.